So we're picking back up on E. And E tells you that the graph of H has 2 points of inflection and found them. Now, if you take calculus next year, you learn how to find points of inflection by hand. You guys are not going to be able to do that this year. So they'll either tell you what the point of inflection is or they'll tell you to approximate it. So you're not going to have to worry about finding the exact unless you take calculus next year. It's not hard, so it's definitely doable. All right, and so we know that's where the concavity changes. So we have concave up, and then we get to about negative 1.68 and the graph changes to concave down. And then you get to where x is 1.68 and it changes back to concave up. So those are the two changes in concavity. And so for the first question, it says for that interval from negative infinity to that first point of inflection, is the rate of change of h increasing or decreasing? So from negative infinity to that first point of inflection, is the graph concave up or concave down? Concave up. So would you say that the rate of change of h is increasing or would you say decreasing? Increasing. Good. So let's just write it out like we would if this was a free response question. So you would say, just kind of quote the problem, the rate of change of h is increasing, and say where, because it changes from problem to problem. So on this interval from negative infinity to negative 1.68. So that's the first part. And the second part says, how do you know? And you know because h is concave up there. Now, I want you to be specific. And I've said this a lot that I don't really know how hard they're going to grade this, but I do know if you say these things, you are 100% right. If you just say h is concave up, it's concave up sometimes, but sometimes it's concave down. So try to be specific about that. Okay, and then we have the next section, which is between the 2 points of inflection. So we're looking at your graph between the 2 points of inflection. What do you think? What's the concavity? Down. Okay, so we are going to answer the question a very similar way. So the rate of change of h is, what do you guys think? Increasing or decreasing? Decreasing, good. And then what's the interval? Because h is concave down there. I think last period we said concave down on that interval, but this is a little bit shorter version. All right, so you guys try G on your own, please. All right, so what are we, concave down or concave up? That's up. So this is up. Sorry, this is up. This is increasing. All right, so I'm hoping, like we've done this multiple times, I'm hoping that kind of stuff is starting to sink in. But we'll talk about it. We'll talk about it with every different function we talk about this year. Eventually, it's going to be there. All right, and then this last one, this is kind of a challenging question. It doesn't feel like it should be, but I think it is kind of hard to get this right. So we're going to sketch a polynomial function, which means we're going to have smooth, rounded terms with an absolute minimum occurring when x is -3. So what we'll do is just go in this negative when x is -3, and we're just going to pick a point to be the minimum. And I would recommend picking a point kind of towards the bottom. That'll make it easier for you to do this problem. All right, and then we have a relative maximum when x is 2. So on that vertical line for 2, we're just going to put a point kind of towards the top, so we make it a maximum, relative maximum. And then a point of inflection when x is -1. So I would pick a point kind of halfway between these two when x is -1, so about right here. It doesn't have to be exactly there. It's going to make it easier for you if you do it that way. Okay, so at that -1, this graph is going to change concavity. So down here, for this to be a minimum, does the graph need to be concave up or does it need to be concave down? Concave up. So that's what we'll do. We'll make it concave up until we get to this point of inflection. And then we're going to change to concave down until we get to the relative maximum, and we still need to continue concave down, at least for a little bit. No, let me ask you a question. Can I just continue? Why not?
Because then it would go past.
Right. We need this to be the lowest point. So this one's going to have a relative minimum also. So, or another one actually. So we would just need to curve back up. Now this is not the only graph. Like your max and min could be closer together. And so when I did the answer key, I did just draw one graph. Your graph does not have to look exactly like mine. So if you're unsure if what you drew was okay, then let me know. I'll double check it. All right. Any questions? All right.